Hello and welcome to our INFR 2830U Operating Systems Final Project presentation. This presentation is based on our process scheduler program, which we implemented in Python and displayed through the use of Kinter and Matplotlib. Following is our workload distribution, demonstration of our project, and references at the end. We are group 21 and our group members are Bilal, Hayden, Mutasim, Marco, and myself, Landon.
I was responsible for the GUI. For the GUI, I decided to go with Tinker, where I coded all the labels and boxes and the buttons. For the input button, it prompts the user to select any kind of input file. For the show update graph, it prints the graph. For the graph, Landon and I, we used Matplotlib.
Alright, so for my portion of the project, I mostly worked on the implementation for the round robin and shortest remaining time algorithms with Hayden and Landon. So specifically for round robin, I implemented Hayden's logic for the algorithm and converted that into Python. And for the shortest remaining time algorithm, I basically just laid out the basic logic of the algorithm and then implemented that into Python.
Now for my division of the workload. I mainly worked on the implementation of our round-robin scheduling algorithm, making sure that the preemption worked. The main issue we were facing with this algorithm was simulating the process control block by storing the remaining burst time of a process that got interrupted, and I assisted with fixing that issue and ensuring that the interrupts for this algorithm were accurate. Since the interrupt implementation was basically the same for shortest remaining time, I assisted with that in that way as well. I lightly worked with the graphing of the coordinates related to each process and how long it would run, and ensuring that the return values of our algorithm functions were in a usable format for the Matplotlib graphing objects that we used for our implementation.
Alright, so I did a small combination of front-end and back-end items. I implemented the color wheel for the GUI so that the user can choose what color they want the lines to be. I also implemented error checking for things such as if there was no color selected, if there was no file selected, if the quantum time was 0, which also played into plotting the line for the graph, and if there was division by 0. I also made use of message error boxes, which you can see on the bottom left. This allowed the user to know exactly what the error was and allowed them to fix them without terminating the program.
For my portion of the project, I first decided the data structure that we would use to store the processes, which was a list of dictionaries with common keys so that we could easily access values like the arrival time and burst time. I then helped finalize the implementation for the shortest remaining time algorithm, so Marco did most of the logic for it, and then Landon found some issues with it, and I fixed the issues. I also implemented the shortest job first and the first come first serve algorithms. And you can see the first come first serve algorithm. I used a lambda function which accesses the arrival time in the list of dictionaries, which is the processes. And I used it as the key function for the sorted function to sort the list based on the arrival times.
Alright, so I will be doing the demo for our process scheduling application. So if you look over here, this is our GUI. So how you want to start off is by clicking the input file button, and you're just going to want to pick a text file, and then you want to set your context switch time and quantum time, and we're just going to leave those as 1 just for now. And you can also select a color, so you can select the color of your graph. So we're just going to pick a red, and all that's left to do is just select your algorithm. We're going to choose round robin and then hit the show/update graph button, and that's going to present your algorithm. So the round robin gives processes a chance to complete their task by having them take turns running for the specified amount of quantum time. After running the process, it is preempted. The process will cycle through running until their burst time is reached. So we can see this with the graph here. So first off, it starts with process 1, then it goes over to 2, and then back and forth from 1 to 2 until 1 is completed. Then it goes from 2 to 3, and and then finally finishes off with 4. Now, let's show off another algorithm. So, maybe I don't want to have a red graph. Let's have a blue graph. And instead of that, let's do first come, first serve. So we're going to set our parameters, and we're going to hit the show/update graph button again. And now we can see our first come, first serve graph. So first come, first serve will fully execute the process according to the process's arrival time. So as you can see, process 1 came first. Then once that's done, it's going to run process 2. And then once that's done, it's going to go to process 3. And then once that's done, it's going to go to process 4. All right. So let's do another algorithm. So let's do shortest job first. So show update graph. So shortest job first will execute the process that has the shortest burst time that is in the ready queue. So as you can see, since process 1 arrives first, it's going to run fully because that's the shortest one. But process 3 is going to run first. Even though process 2 arrives before 3, it has a shorter execution time. So it's going to run process 3, then it's going to run process 2, and then finally it's going to run process 4. So let's change our file here, shall we? Let's do test 2, and let's do shortest remaining time first. So show an update graph. So shortest remaining time first is the preemptive version of the shortest job first algorithm, meaning it will execute the process that has the shortest burst time. But if a process with a shorter burst time arrives in the ready queue, it will execute that process instead. So as you can see, it's going to run 1 for 1 second, and then it's going to run process 3, and then it's going to run process 4, that's going to go back to 1, and then it's going to finish off with process 2. And it's going to execute in the order of whoever has that shortest time. So that's our project. Thank you very much.